Firstly, introduction. For scope, it uses a vapor compression cycle with 141B as its working fluid, and water is used as a fluid with high thermal mass, and data is taken limited to temperature and taken at 7 different points in the cycle. And the objective of this experiment is to determine the coefficient of performance CE for vapor compression cooling system.
Okay, for the theory, we would need to calculate the coefficient of performance, COP, which would be calculated using the formula Q over W, with Q being the heat, heat supplied by the cold reservoir divided by the work used by the compressor.
So hi for the experimental setup. So as we can see in this slide, there will be a video and also a picture that show the apparatus, which is refrigeration cycle demonstration unit. So first of all, there will be the condenser water flow meter, and then the evaporator water flow meter, and then there will be a part that we can read the temperature, which is T1, T2, T5, and also T3, T4, and T6. And at the bottom, T7. And then there will be watt meter, temperature indicator, temperature selector switch, and last but not least, there will be 2 condenser water flow meter. That's all. So, hi for the methodology. First step, we open the valve that already shown in the lab manual. So basically, at the lab, we will given the lab manual that shown what the valve that we will open, and then with the pipe is open, and the water flow rate of the evaporator is set up to 25 G per second, and then while the water flow rate for the condenser is set up to maximum. Okay, you can see in the video. After that, we open the switch is on, and then we will wait for 10 minutes until the system is stable, and then take all the reading to fill in the table. After that, we will repeat this experiment 4 times by changing the flow rate of water to condenser. That's all. Thank you.
So, included are the results of our experiment. We have calculated and measured few things in this experiment, which include the absolute condenser flow rate, the condenser gauge pressure, evaporator flow rate, the gauge pressure of the evaporator, and the compressor power input. We also evaluate the temperature at 7 different points, and the rate of heat transfer at the evaporator and the condenser, as well as the coefficient of performance. So we can see one by one, but in summary, the temperature at 0.1, 0.4, and 0.7, 0.6 and 0.7 are the highest, while the temperature at 0.2, 3, and 5 are lower. This is caused by the position of the 3 locations where we record temperature, which 1, 4, 6, and 7 being at the left. Okay, for our discussion, we can see from the graph shown here that the rate of heat transfer for the evaporator initially decreases between the first and fourth run, and suddenly it increases at the fifth run for some reason. And on the other hand, the rate of heat transfer for the condenser initially decreases between the first and second run, but gradually increases. Unfortunately, this does not correspond to what should actually happen, as the rate of heat transfer for both evaporator and condenser should both approach towards zero as the experiment progresses, because the flow rate is gradually decreasing, which lowers its capacity to transfer heat. So both one would go down, another would go up. So for the second part of the discussion, from the graph of compressor power input against absolute condenser flow rate, it is seen that the compressor uses the most energy at the lowest flow rate, and gradually decreases until a point where the power input would not decrease, even though the flow rate is much higher. This happens due to the compressor not being able to slow down more than its minimum speed to complement the flow rate of the input water. Hence, it can be concluded that 220 watts is the minimum power draw of the compressor.
Okay, next, safety procedure. First, student must wear appropriate attire during lab session, like lab coat and closed shoes. Second, make sure all the equipment are in good condition before start the experiment, and make sure to wear heat-resistant glove before touching a hot surface, and ensure all the electrical connection are in good condition to prevent electrical shock. And lastly, make sure to follow the shutdown procedure to avoid damage to the equipment.
From the experiment, we found out how does a vapor compression refrigeration system work and how does it transfer heat from the evaporator to the condenser. We also determined the coefficient of performance for the vapor compression refrigeration system, which turned out to be 1.4, 0.23, negative 0.17, negative 0.55, and negative 0.005. And flow rate at 25, 20, 28, 10, 25 grams per second. It is found out from the result that the COP of the system gradually decreases, then suddenly increases when the flow rate of the condenser decreases. It is also seen that the compressor power also increases and the condenser flow rate increases. While running the experiment, there are errors which contribute to the inaccuracies in the data obtained, such as the position of the ice, the way perpendicular to the scale reading of the thermometer. Hence, to overcome the error, it is advisable to make sure that the position of ice are perpendicular to the scale reading of the thermometer.